This episode is brought to you by Cisco Educational Premium. In the case that Q is a conserved quantity that cannot be created or destroyed, such as energy, sigma is equivalent to 0, and the equations become partial rho on partial t plus del dot j is equivalent to 0, as shown. In electromagnetic theory, the continuity equation is an empirical law expressing local charge conservation. Mathematically, it is an automatic consequence of Maxwell's equations. Although charge conservation is more fundamental than Maxwell's equations, it states that the divergence of the current density J in amperes by square meter is equal to the negative rate of change of charge density rho in coulombs per cubic meter. Del dot J is equivalent to negative partial rho on partial t. One of the Maxwell equations, Ampere's law with Maxwell's correction, state as shown. Taking the divergence of both sides, the divergence and the partial derivative in time commute results as shown. But divergence of a curl is 0. So we have also, but Gauss's law, another Maxwell equation, states del dot d is equivalent to rho, which can be substituted in the previous equation to yield the continuity equation del dot j plus partial rho on partial t is equivalent to 0. Current is the movement of charge. The continuity equation says that if charge is moving out of a differential volume, like the divergence of current density is positive, then the amount of charge within that volume is going to decrease. So the rate of change of charge density is negative. Therefore, the continuity equation amounts to a conservation of charge. If magnetic monopoles exist, there will be continuity equation for monopole currents as well. In fluid dynamics, the continuity equation states that the rate at which mass enters a system is equal to the rate at which mass leaves the system, plus the accumulation of mass within the system. The differential form is as shown, where rho is fluid density, t is time, and u is the flow velocity vector field. The term derivative can be understood as the accumulation or loss of mass in the system, while the divergence term represents the difference in flow versus flow out, in flow in versus flow out. In this context, this equation is also one of the Euler's equations. In fluid dynamics, the Navier-Stokes equation forms a vector continuity equation describing the conservation of linear momentum. If the fluid is incompressible, volumetric strain rate is 0, the mass continuity equation simplifies to volume continuity equation del dot u is equivalent to 0, which means that the divergence of the velocity field is 0 everywhere. Physically, this is equivalent to saying that the local volume dilation rate is 0. Hence, a flow of water through a converging pipe will adjust solely by decreasing its velocity as water is largely incompressible. In computer vision, optical flow is the pattern of apparent motion of objects in a visual scene. Under the assumption that brightness of the moving object do not change between two image frames, one can derive the optical flow equation as shown, where t is time, xy coordinates are those in the image, I is the image intensity at image coordinate xy and time t, v is the optical flow velocity vector, vx, vy at image coordinate XY, and time T. Cisco Educational Premium is a section of Cisco Educationals with content that is not hosted here. There are episodes ranging from long to short videos. Remember those good old shots of ours? They are there. So do we get there? Use the link on screen or in the description or in the pinned comment below. Enjoy yourself. And I will see you in the next episode of Cisco Educationals.